Hi, I'm going to be doing a few of our review problems. So I'm going to start with 1 and 4 on our review. In both these problems, we're being asked to determine the type of roots, real or not real. So I'm not being asked to find my roots. I don't want to know what x is equal to. I want to know, for example, if I have 2 real roots because my graph would intersect the x-axis twice, or maybe I just have 1 real root because my graph touches the x-axis, or maybe my graph is above the x-axis, the vertex, and it goes up, for instance. And in this case, there would be no real roots. Instead, these roots would be complex and or imaginary, and so I would have 2 non-real roots. So this is from our 9.3 notes on the back side where we learned about a discriminant. So for number 1, I actually don't have an A, B, or C to use in my discriminant because the discriminant is what's underneath my square root symbol in the quadratic formula, b squared minus 4ac. So I have 1 or 2 options here. One option would be to write this twice and multiply it out. Don't forget to add 7 to your constant term. And then I would have my A, B, and C, and I could put it into my discriminant. However, since it's in vertex form, I learned in Unit 3A how to graph this. So I know my vertex would be at 2, 7. So my vertex is here somewhere at 2, 7. And since my A is a positive 1, I know my graph would go up. So I can tell just from looking at my graph that I would have no real zeros, and I know that I would have 2 then non-real zeros. And if I solved this, I know that I would be getting an I in my answer for x. And if I did the discriminant, I would be getting a negative number for my discriminant. So I know that I have no real zeros. In fact, I have 2 non-real zeros. So let's take a look at number 4. My A is 1, my B is 5, and my C is negative 8. So if I put it into my discriminant, I would get 25 minus 4 times 1 times negative 8. So I'd get 25 plus 32, or 57. This would be 2 real zeros because 57 is greater than 0, so I know that I would have 2 real zeros. If my discriminant was equal to 0, I would have 1 real zero, and if my discriminant is negative, like it would have been for number 1, then I would have no real zeros. That's telling me that I would have 2 non-real zeros. So let's take a look then at the next page at, for example, number 14. So number 14, 12 through 14, this is from section 9.1, where I learned to solve by taking the square root. So let's take a look at this problem. If I wanted to solve this, the very first thing I would have to do is trying to isolate my x plus 2 squared term. So I'd want to add 3 to both sides to move it away, and I get 3 equals negative 1/2 x plus 2 squared. So now to continue isolating x plus 2 squared, I'd multiply both sides by negative 2 over 1. My 2's cancel, my negatives cancel, and I would just be getting x plus 2 squared on the right side. On the left side, I'd be getting negative 6. So the next step would be to take the square root of both sides. So this is also going to highlight 11.2 when we learned how to do imaginary numbers. So on the right side, I get x plus 2. However, on the left side, the square root of 6 would be simplified, but the negative 1, because this is negative 1 times 6, the square root of negative 1 we know is I. So this guy would give me I rad 6. And don't forget, since I'm doing a quadratic equation, I'd have plus I rad 6, and I'd also have negative I rad 6 as my 2 answers. And so my last thing to do is to subtract 2 from both sides. I'm just going to stick that in front of my plus minus. So my final answer would be x equals negative 2 plus minus I rad 6. So now let's talk about a completing the square problem. I'm going to actually do number 16 because you can work with some fractions in number 16. So on number 16, I can't start completing the square because my a is not 1. So I'm going to divide everything, both sides of the equation, by 2. I get x squared plus 5x plus 2 equals 0. So now I'm ready to complete the square. The first step is to set up to complete the square. I'm going to subtract 2 to the other side. X squared plus 5x equals a negative 2. So now I'm going to complete the square. So I need to figure out what number makes this a perfect square trinomial. So I do 5 divided by 2 and I square it, which is 2.5 or 5 halves. And then when I square it, I get 25/4. So the number I have to add to make a perfect square trinomial is 25/4. If I'm going to add that to the left, I better add that to the right. And this creates a perfect square trinomial where the middle step, the 5 halves, is what's in my parentheses. And if you're writing this as 2.5, that's perfectly fine. So I get x plus 5 halves squared on the left, and on the right, I have to work this out. So this is 2 over 1. So if I want to change it to something with a denominator of 4, I'd have to multiply both the top and the bottom by 4. I'd get negative 8 over 4. And negative 8 plus 25 would be 17. So on this side, I'd have 17/4. So now let's solve this by taking the square root of both sides. So I take the square root of both sides, and over here I get x plus 5 halves. And on this side, I get plus or minus the square root of 17 over 4. However, that's the same thing as off to the side, the square root of 17 divided by the square root of 4. 4. And I know the square root of 4 is 2. So I'm going to write this as the square root of 17 over 2 because the square root of my denominator 4 is a 2. So let's finish this one off by subtracting my 5 halves over. I get x equals negative 5 halves plus or minus the square root of 17 over 2. So this guy could be finished here. It's got a common denominator of 2. You could write this as negative 5 plus or minus the square root of 17 over 1, 2 if you wanted to. Or if you're using decimals, that would be more than fine. But your decimal, you should have negative 2.5 plus whatever the square root of 17 over 2 is, and negative 5 halves minus whatever the square root of 17 over 2 is. Decimal answers would be fine there. So let's take a look. I think we did a lot of the factoring in class today, but I'm going to go ahead and look at number 22 with you. So number 22, I cannot divide these terms by 3. So this is a problem where my a is not equal to 1. So the first thing I use is my diamond method. When I set up my diamond method, I multiply my a times c and I get 15 at the top and I have my b at the bottom. So now I'm trying to think of what multiplies to 15 while adding to 16. And so I'm thinking in my head, and I think of 15 and 1. 15 times 1 is 15, and 15 plus 1 is 16. So I rewrite this as 3w squared plus 15w plus 1w plus 5 equals 0. Doesn't matter what order I put the 15 and the 1 in, it could be in either order. So factor out a GCF of 3w from my first two. That leaves me with a w plus 5. And I already have a w plus 5 from my last two. So I'm just going to factor out a 1, and I have my w plus 5. So now, if I factor out my w plus 5 from both terms, I would have a 3w left over, plus 1 left over. And so this is fully factored. And now I would set each of those equal to 0. And so my w plus 5 equal to 0 would give me a w equals negative 5. And my 3w plus 1 equal to 0 would give me a 3w equals, what is that, negative 1. So w would be negative 1/3. So this next problem, my rectangular porch has the dimensions x plus 3 and x plus 4, and the area of the porch is 132. We had a homework problem exactly like this. So I would start my problem by writing x plus 3 times x plus 4 equals 132. I get that because the area equals length times width. So if this is my length and my width, I would multiply them to get then my area. So this problem, I would have to multiply this with box method or FOIL. I'd have to move the 132 over. I would need to work it all out and have it equal to 0. And then I would continue solving this problem. This problem is factorable, but you could use completing the square quadratic formula, although that would be more work. So flipping it over to the next side, let's take a look at number 25. Number 25 can be done two different ways. One way, I can use completing the square to do it. And I'm going to do that first. And when I get done, I will talk to you about another way to do it using negative b over 2a from unit 3a and the quadratic formula. So for starters, let me write my equation for the height. My equation for the height would be negative 16t squared plus my initial velocity, which is 64 feet times t, plus my initial height, which is 8. So I'd like to find the maximum height of the ball, which means I need to find my vertex. So I'm going to use completing the square to write this in vertex form. Ultimately, I'd like to get it into the form where I have my a times my t minus my h squared plus k. That's what I'm looking for. I'm looking for vertex form. So here we go, you guys. I'm going to write my negative 16t squared plus 64t together. These are the two I'm going to use completing the square to get something of this form. I'm just going to write my plus 8 out to the side. I'm not moving it to the other side. I'm just scooching it over a little bit. So I'm going to pull out a negative 16 and I get t squared. What would that be? Minus 4t, and leave a space plus 8. I have not changed my equation at all. If I distribute the negative 16, I get back the same 3 terms I had before. So to keep working it down, this is the step where I would like to complete the square. So in this problem, my b is negative 4. So I'm going to do negative 4 divided by 2 and square it. I get negative 2 squared, and I get a 4. So if I add 4 to t squared minus 4t plus 4, that perfectly factors into t minus 2, that's for my middle step, squared. So 1, 2, 3, this perfect square trinomial factors into this binomial squared. I've got a lot of other working parts I've got to fix now. So I have a negative 16 out in front. And this plus 8 is no longer plus 8 because I've now created a problem. I have added 4 into my equation that wasn't there before, but technically I didn't add a 4. This is negative 16t squared plus 64t, and this guy right here would give me a minus 64 when I distributed the negative 16. I really put a negative 64 on the right side of my equation. So I'm going to also add 64 on the right side of my equation. This 64 that I'm adding cancels this negative 64, and really my equation remains unchanged. So 8 plus 64 would give me a 72. So this looks like the vertex form of my equation would give me negative 16 times t minus 2 squared plus 72. So my vertex is at 2, got to think the opposite, 72. So at 2 seconds, my ball would be 72 feet in the air. So my max height is 72 feet. So if you've done that work to find your max, you might as well just use this work to solve it. So to solve when it hits the ground, my height, h of t equals 0 when it hits the ground. So for h of t, I'm going to put a 0 in. So if it's okay with you, I'm going to write the negative 16 times t minus 2 squared plus 72 on the left. And I'm going to write my h of t, which is now 0 on the right. I really like my variables on the left. So now I'm going to subtract my 72 over because I'm solving for my squared term. So I get negative 16 times t minus 2 squared equals negative 72 over here. I'm now going to divide both sides by negative 16. Okay. And so I get t minus 2 squared equals, now it's positive 72 over 16. That reduces down to 9/2 if you want to do that technically I'm going to put all this in my calculator, so it doesn't really matter if I reduce this or don't reduce this at this time, because I'm going to put it all in my calculator in the end. So I'm going to take the square root of both sides, and I get t minus 2 equals plus or minus the square root of 9/2. Technically, I could play with that a little bit, or if I had left it up above, I could have a 4 on the bottom. Since it's time, I'm going to put it in my calculator. It doesn't really matter what stage my work is in right now. So I'm going to add 2 over and get t equals 2 plus or minus the square root of 9/2. You're going to want to get out your calculator and plug this in to get your 2 times. When you do this, you should get that your time equals 4.12 seconds or time equals negative 0.12 seconds. Since it doesn't make sense to have negative time, we don't use this. I think I'm writing on multiple papers. Sorry about that. So my answer for this one would be 4.12 seconds. So let's say this is all from section 9.2, and this is our day 2 notes. So let's say you don't want to use completing the square to do this problem. You actually don't have to. Let me get a different colored pen. You could solve this problem going back to Unit 3A. You could do this side over here very quickly by using the fact that your x, or your t in this case, is equal to negative b over 2a. When you do negative b over 2a with these numbers, you're going to get a 2. You plug a 2 back in for t, and you're going to get a 72 for your y. So that's how you could figure out your max height. And then, if that's how you did that, then I probably would not use completing the square to solve this problem. I might use quadratic formula, where your a is negative 16, your b is 64, and your c is 8. I mean, it's just like you're not stuck using completing the square if you want to think about it that way, because you didn't use it for part A. If you want to see how this looks for number 29 in the locker, when I did number 29E, when will the ball's height, be at a maximum? I did this, I believe, in both methods. So you can check it out that way there. So let's talk about complex numbers. Let's take a look at number 28. So number 28, this is simply FOIL or box method. It depends on what your preference is. So I'm going to write my negative 1, 4i across the top, and my 3 minus 8i along the side. Now I need to multiply. When I multiply 3 times negative 1, I get negative 3. 3 times 4i, I get 12i. Negative 1 times negative 8i, I get positive 8i. And a negative 8i times a positive 4i should give me negative 32i squared. I'm going to do something with that I squared, but I'm going to wait a moment. So my answer would be negative 3. These two in here give me what? Plus 20i, and then minus 32i squared. So I squared is not simplified. I know what I squared is. I squared is equal to negative 1. So I need to think about that as negative 32 times a negative 1, which is really a positive 32. So this is equal to negative 3 plus 20i plus 32. And so I need to combine my minus 3 and my plus 32 because they're like terms. When I do that, I get, I believe, 29. You need to write the 29 in front because that's your real part. You need to write the plus 20i in the back because that's your imaginary part. This is my complex number where my real part is first and my imaginary part is second. If you remember in our notes, we talked about complex numbers being a plus bi. The a would be my real part, 29, and the bi would be my imaginary part. That's like my 20i here. So that is going through some of the problems on your homework assignments. Number 29, I'm just going to pick a couple things that I want to talk about on this one. I think from my work you can see a lot of it. I want to mention B, C, and D are all very similar. In all of these, I'm giving you different heights. So for B, for instance, you're setting this equal to 3. For C, for instance, you're setting it equal to 163. And for D, you're setting it equal to 220. So when you're solving it, it depends on what method you want to use, but always you have to get it set equal to 0. So when I set this for part D, for example, equal to 220, so 220 equals negative 16t squared plus 112t plus 3. I can't do anything until I get this set equal to 0. So I'm going to need to move the 220 over to the other side, or add this over, subtract this over, subtract this over. It doesn't really matter what direction you want to go here. But I need to subtract the 220 over so that I have my problem. What would that be? Negative 217. So that I've got it set equal to 0. Now, if it's factorable, you could factor. Now, if you wanted to complete the square, you could begin the process to complete the square. And if you wanted to use quadratic formula, you could use quadratic formula. I believe in our notes I use quadratic formula, but I want to point out something interesting that happens here. So this is my A, this is my B, this is my C. So using my quadratic formula for t, whether you write a t or x is really okay for me, but I'm solving for my variable. In my quadratic formula, I would have a negative b, negative 112, plus or minus the square root of 112 squared, that's my b squared, minus 4 times my a, which is negative 16, times my c, which is negative 217, all divided by 2 times a. When you do this math, cranking out all this math right here, you're going to get a negative number underneath your square root. That is assigned to you like in our homework problems for section 9.3. I'm going to stop when I get, I believe on the next line down, this is negative 112 plus or minus. This would be negative 32. Underneath the radical, when you multiply this by squaring it, you multiply this times this times this, you get a negative number. I believe you get like a negative, it's a large number. I don't have a calculator near me. Let me glance at the board. Sorry. You get negative 1,000, I believe 344. I think that might be what you get. This guy would give me an imaginary number. When I take the square root, I would have an I. That's telling me that this never happens. There's never a time where I reach 220 feet as a height. So that this problem doesn't exist. There's never a time that I'm going to be 220 feet. And I know that because I get a negative here. So I would stop and I wouldn't continue the problem, because I would have an imaginary answer for it. So it doesn't exist. I think at that point, I'm done working out problems for right now. If you have any other questions, please don't hesitate to email me or come see me to ask me about them. Thank you.